So I was hoping to show an alternative for the long division methods of dividing that we've had. Recall that when we've done long division on a problem like this, it's got a lot of steps, but just to review that, and then we'll do the new method or an alternative method that I learned from a colleague. So here we go. Here's the problem. It looks like it takes forever, but let's see what happens. Remember, 3x goes into 6x to the fourth, 2x to the third times, and we multiply that. We get 6x to the fourth minus 4x to the third, and then we go and we subtract. I should probably put my subtraction in a different color. And then we bring down, these are gone, and we're left with negative 3x to the third, and we bring down the next term, and so forth. And then we say, well, let's see what we got now. We got 3x goes into negative 3x to the third, negative 3x squared times. It's one power less, but the 3 is already there. Negative 3x the second times. Or wait. What am I doing? Just already got the 3. So 3x goes into negative 3x to the third time, x squared times, sorry. So then we multiply negative x squared times there, and we get negative 3x to the third. Negative x squared times minus 2 is positive 2x squared. Again, we're going to change our signs to subtract. So we end up with this thing. Let's see. These are gone, and we end up with 9x squared, and we bring down the next 9x. 3x goes into 9x squared. How many times? 3x goes in there 3x times, because 3x times 3x is 9x squared. And we multiply the next one, and so forth. And eventually we'll be done with it. Let's see, negative 3x, and here's the last one. 3x goes into negative 3x one time, or negative one time. Negative 3x plus 2. Change your signs, and we end up with 3 remaining. So a remainder of 3. So that's what we end up with in the traditional long division method. This would be a hard problem to do synthetically without a little understanding about what to do with that 3x out in front there. So hopefully I'll get the same answer when I do this alternative method. I can remember how that works. It looks like this. We would have one of the factors, 3x minus 2 on the short side, and we'd start with a 6x to the fourth. The idea here is that if we can think about this as a box and say, well, 3x minus 2 times something equals 6x squared, 6x to the fourth minus 7x to the 3, all the way down to the 5, we can just fill in the box as we go along. And let's see how that works. So 3x goes into 6x. 3x times what makes 6x to the fourth? Well, 3x times 2x to the third. Now, 3x times 2x to the third makes 6x to the fourth, but we also have this negative 2 down here. So 2x to the third times negative 2 makes negative 4. Now, think about this for a second. What we're trying to do is we want these two things to add up to negative 7x to the third, because I know that the like terms are usually along those diagonals. So you say to yourself, well, I must be missing negative 3x to the third, because I'm supposed to have negative 7 of them, right? So because that negative 3x to the third is there now, I can say 3x goes into negative 3x to the third. 3x times what makes negative 3x to the third? Well, negative x squared. But you can multiply negative x squared times negative 2, and make positive 2x. So you see we're kind of creating the answer by kind of going backwards here. All right. Now, these are supposed to add up to 11x squared. So the missing one must be 9x squared, because I have 11x squared. 3x goes into 9x squared 3x times. Okay, so 3x times negative 2 makes negative 6x. And once again, I'm going to say these two numbers have to add up to negative 9x. So the missing thing is negative 3x. And notice a lot of the same numbers are appearing here as in the last problem, but this might be easier for a lot of people. 3x times what makes negative 3x? Negative 1. Negative 1 times negative 2 makes 2. And I'm supposed to have 5. So this thing must be a 3 over here. Now 3x times what makes 3? Well, nothing, because 3x doesn't go into 3. So that must be our remainder. So our answer is 2x to the third minus x squared plus 3x minus 1 with a remainder of 3 over 3x minus 2. And hopefully that's what I got the last time, but I erased it, so I don't know to look back on it. So this way of going backwards, that's the way we do these problems. Now, I'm going to do 2 more problems as examples if you want them. Okay, there it is. How about that? So this was a problem from the long division slides, and the way I would set it up that's different. So I wouldn't exactly set it up like that, I guess, because I'm not sure exactly how long they are. I'm not so good at these things, but I think that it's going to have an x minus 3 over here, and I know that the beginning part is an x squared, right? Because that's from here. So x times x makes x squared. X times negative 3 makes negative 3x. But these two have to add up to positive 4x. So this must be a 7x over here. X goes into 7x 7 times. 7 times negative 3 is negative 21. These two must add up to positive 5. So this must be a 26 here. 26 minus 21 is 25. So x does not go into 26. Therefore, my answer is x plus 7 plus 26 over x minus 3, which is from the original 4.3 notes, that example. We'll try one more, and try it first on your own. Try this first on your own using that alternative method, and we'll try to get a pause now. All right, let's see. X plus 2. Let's see. And I'm going to start with 3x to the fourth. Okay, x times 3x to the third makes 3x to the fourth, making this 6x third down here. Now these are supposed to add up to 0 because there are none of them, so I'm going to put negative 6x to the third in there. X goes into negative 6x to the third, negative 6x squared times. Now, if you are feeling like you're getting it and you didn't get it before, you might want to pause now before I finish this to try it on your own. All right, let's see. Negative 6x squared times 2 makes negative 12x squared. These two have to add up to negative 5. So I've got negative 12, so I've got to add 7x to 7x squared to them to make negative 5. X goes into 7x squared, 7x times. 7x times 2 makes 14x. These are supposed to add up to 8x, so this has got to be a negative 6. X goes into negative 6x, negative 6 times. Negative 6 times 2 makes negative 12. These two have to add up to positive 1, so it must be 13. X doesn't go into 13, so that must be my remainder. So 3x to the third minus 6x squared plus 7x minus 6 plus 13 over x minus 2. Of course, the only reason why I use this one is because I tried it before in other notes, but of course you could use synthetic division, which would of course be a lot easier in this problem, I would imagine. So that's an alternative to long division.